So welcome back, I'm Clinton the Tech Pro, and today we are going to continue with question 8 on our data science question and answer series. And the question for today is, what is the coefficient of determination R squared in regression? So this is important. This is an important question that you might encounter in a data science quiz or interview or some assessment. Now, the coefficient of determination R squared in regression is a measure of how well the regression model represents the data set. It provides the proportion of variance of one variable that results from the other variable. In other words, it is the ratio of the explained variation to the total variation, and it takes a value between 0 and 1. So we have that 0 is less than or equal to R squared is less than or equal to 1. So if we have a coefficient of regression to be R is equal to sometimes, okay, R squared R is equal to 0.922. That means that R squared is equal to 0.850, which is equivalent to 85%. So this means that I'm going to use a different pen to write this time. It means that 85% of the total variation in the data can be explained. 85% of the total variation in Y can be explained from X. So basically we have something like this. I like to use a different color so that we will be able to differentiate. So if we have X and we have Y, X1, X2, X3, X4 all the way, Y1, Y2, Y3, Y4 all the way. So we come out with some linear regression or some regression we've come out with, maybe something like this, blah, 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 and we have a regression line. How good is this regression? This regression line is telling us that there's a relationship between the two, between X and Y. And we are saying that R squared value, high R squared value is telling us that there is a strong relationship between X and Y. But lower value of R squared is telling us that there is there's little relationship between X and Y. So it's pretty intuitive. So what I'm going to do now is that I'm going to write out the formula for R squared. This is just for you to know, not necessary for you to memorize it, but in case you want, you can just memorize it. R squared is equal to 1 minus the expected value of Y minus f of X, okay, squared, divided by expected value, this time is the total, Y minus expected value of Y squared. So this is just the formula, just in case for you to know. And before I round off, let me just outline a few properties of R squared. So let me just outline properties of R squared. So the first one that you already know is this property that says that 0 is less than or equal to R squared is less than or equal to 1. All right. Another property says that if X and Y are independent, meaning no relationship, independent, then R squared is equal to 0. And the next one says if actually Y is a function of X, then R squared is equal to 1. Remember that once we come out with f of x is equal to y. This is our estimate. We are just trying to assume that there's a relationship and this is a function that relates them. But in the real sense, we don't know. So this is just estimate. We are not sure exactly what is happening there. So, but if actually these two data is related, these two pieces of data is related, then we'll have this to be true. And finally, if the joint distribution of x and y is normal, let me just write it. If the joint distribution of x and y is normal, then r squared is equal to r x y squared. Now I cannot explain this at this point, so this is just for your information. Actually, I'm going to stop here, but I'm sure I've given you what you need to understand these concepts and be able to explain it in your own words, and also be able to use minimal notations and diagrams to be able to explain it. So we'll see in the next question, that is question 9, which is, let's see, it says, what do you understand by the Nadaraya methods?